First of all, what is networking devices? Okay, networking devices. What is networking devices? Networking devices are nothing but the devices which allow hardware on the computer network to communicate with each other. That's it. Which allow the hardware on the computer network to communicate with each other. This is the simplest definition you will ever see. Example, you have a device A, you have a device B, okay? Device A wants to send the data to device B, okay? Now, device A, suppose it's sitting in India, okay? Let's suppose device B is sitting in USA, okay? India to USA. Now, the data has to travel from India to USA, okay? Now, first of all, A produces the data. Now, we have one device which is present in all the nodes. Node is nothing but the end device, okay? We have one the device which is present in all the nodes, which converts the data bits generated by the computer to signals, okay? That is nothing but NIC. NIC is a networking device which converts the data generated from the computer to the signals which are traveled through Ethernet or optical fiber or anything else, okay? Now the data travels as signal. Now to get out of the network, okay, this A device is present in some LAN. Example, I have my home LAN, my router is sitting right there, okay? My mobile phone is trying to send data to the phone to my one of my friends who is sitting in USA. Okay, now the NIC sends out this signal. Suppose these are radio waves. Suppose these are radio waves. Okay, now we have router sitting here. Router is nothing but the device which forwards the packets on the basis of their IP addresses. Okay, each and every frame has MAC address. Okay, it will first go to router. Now this router will keep on forwarding on the basis of the IP addresses. Okay, now router forwards to, we have one more device called as modem. Okay, actually in today's generation routers have built-in modems. They have built-in modems, but let's suppose the modem is a separate device. So modem is the one which modem is called as modulator and demodulator. Okay, modulation is nothing but the process of converting digital signal to analog signal. Okay, and what is demodulation? Demodulation is nothing but the process of converting analog signal to digital signal back. That is nothing but demodulation. Now the modem is the device. Modem has two ports. Okay, modem has two ports. Modem has one port called as LAN port. Modem has other port called as ISP port or WAN port. So modem is the one which actually brings internet to your local area network. Okay, so modem connects to ISP. ISP is nothing but internet service provider. Example, Airtel, Jio, okay, BSNL. These are nothing but ISPs. Okay, which now modem is the one which connects to ISP. Now from ISP it will go to internet. That data which you created, it will go to internet. Then from internet it will go back to modem, to ISP, again to modem, again to router, again to the correct device which is present in the local area network of USA. That's it. That is the networking device. So these are the devices, the names which I have taken. These are the devices which actually are responsible for sending the data from one device to other device. Okay, and we have some devices within the local area network. If we have one LAN, we have some devices within the LAN which enable effective communication. Example, suppose I have one LAN A, B, C, D. Okay, these are interconnected. Okay, now within a LAN we have some set of devices which allow effective communication. The first device is hub. So hub is a device. Okay, I don't want to tell the entire definition right now. Right now you can think hub is a networking device. We have hub, we have switch, we have repeater, okay, we have bridge. and we have gateway. So these are within the LAN devices. These are the devices which are used within the LAN itself, not above the LAN. So above the LAN are nothing but, I mean, forward to the LAN are nothing but router, modem. NIC is also within the LAN, but as it is responsible for creating data and not creating data, as it's responsible for converting the data into signals. That's the reason I mentioned here. Okay. So these are inter-LAN devices. Okay. Now. Okay. Let me start networking devices with. Let's start networking devices with repeater. Okay. First of all, what is repeater? Repeater is a networking device which is used to amplify the signal. Okay. Now, what does it mean? Okay. Coming to it. What does it mean? Suppose we have device A. Suppose we have device B. Now device A and device B are located far apart from each other. Now what happens? A generates a signal. Device A, NIC of device A generates a signal, which is actually a digital signal. Example is a digital signal 0 1 0 1 0 1 0 1 0 1. Okay, this is a digital signal. Now, so as you know, the signal strength is represented by the voltage levels of a signal. Okay, the signal strength is represented by voltage levels, right? We have graph here. Okay, 0 1 0 1 0 1. You know it, right? How does digital signal looks like? These are nothing but square waves. Digital signal is nothing but a signal which carries data in discrete format, nothing but binary values. 0 1 0 1 0. This is nothing but digital signal. Now, suppose these are digital signals which are traveling over Ethernet. Let's suppose this is an Ethernet cable, Ethernet fiber or Ethernet cable. Okay. Now this is getting transmitted as in the form of electrical pulses or digital signals. Okay. Now, as the distance is more, what happens is, once you generate the signal here, it will be very, very strong. As it goes forward, the signal strength gradually reduces. It is a common sense, right? If you shout from here, your voice will go up to a certain range. In the same way, here, once the signal gets generated, after reaching a certain period of time, the signal strength will reduce. Then later, the signal will look something like this is flat. It will come on becoming flat, right? Then once it becomes flat, the receiver device will not be able to decode the data. Suppose if you are sending 1 0 0 1 0 1 0 1, receiver will decode like 1 0 1 0 0 0. Everything is zeros because the signal is flat. The digital signal is flat. This is not right. If you are selling hello and if I receive something like helium, if I receive something else, there is of no use. That's the reason. That's the place where repeaters come into use. Repeaters are nothing but they have two ports. Gradually 2 to 4 ports, but generally repeaters have 2 ports. Okay. One is incoming port, one is outgoing port. So incoming port is responsible for taking the weakened signal. Okay, regenerate the signal bit by bit and then amplify it, boost it. Now repeater sits somewhere here. So this device is now responsible for taking this signal, regenerating the signal and boost it. It will give the correct shape of the signal so that it can travel to still amount of random distance. Now, by this you can say repeater is responsible for extending the network range. Repeater is responsible for extending the network range. Okay, got this point? And repeater allows only half duplex. Repeater allows half duplex communication. What is half duplex communication? A device and B device. There are two devices. A device can send and receive. B device can send and receive, but not at the same time. Okay. If A is sending the data now, B has to shut up and wait for that data. Okay. Only after B receiving that data, only if the medium is free, only then the B is going to send the data, or else it cannot send. That is known as half duplex. Okay. Anytime any one person can speak in a room, that is nothing but half duplex. Got it? Okay. So I told repeater has 2 ports. It is nothing but responsible for extending the network range, and it is responsible for regenerating the weakened signal and amplifying, nothing but boosting it. That is about repeater. Okay. Now repeater is of multiple types. Okay. The first type is digital repeater. Digital repeater. So digital repeater is nothing but a device which is responsible for receiving the weakened digital signals. Okay. This is what the repeater which is sitting here, the repeater which is sitting here is nothing but digital repeater, because it's taking digital signals, weakened digital signals, and amplifying and regenerating and sending out the strong digital signals. That's it. That is nothing but the digital repeater. We have one more type called as analog repeater. You can say the definition by seeing itself. Analog repeater is nothing but which accepts weakened analog signals and sending out the strong analog signals, regenerating it by amplifying, boosting it. That's it. We have one more repeater called as optical repeater. You can say these two. Okay. The repeater which takes in optical waves, nothing but light pulses. Optical waves are nothing but light pulses, which accepts the light pulses, weakened light pulses, and sending out the stronger light pulses. Okay. These 3 types, and we have 2 more types. One is wired repeater. One more is wireless repeater. Okay. So now what is wired repeater? Wired repeater are nothing but the repeaters which work on physical medium. Nothing but the wired medium. Example what? Okay. Example what I showed here. Ethernet. Ethernet is nothing but wired, right? Ethernet is wired. These are wired repeaters. Okay. Now what are wireless repeaters? Example. Radio wave repeaters. Okay. The repeaters which work on wireless medium. They don't have any physical connection like cable connecting those. Okay. They are just like they accept the incoming radio waves. They amplify the radio waves and send it back. Okay. Example hotspot connectivity or Wi-Fi connectivity between you and your router. Between they will have that repeaters. Okay. Now let's learn about hub. Okay. I explained you about hub topology. So actually I call hub a dumb device. Why? Because it is not intelligent. Okay. It doesn't have any common sense. What it does? Okay. First of all, what is hub? It is a networking device which is used to connect multiple devices and forward the packets or frames sent by any device to all other devices. Now I should stress some point. Example. So let's suppose I explained you about hub topology. Okay. We have a central concentrator called as hub here. Okay. The hub is sitting here. Now we have A device, we have B device, we have C device. Now what actually happens here? Suppose if A device wants to send some data. Suppose A is trying to send the data to C. Now A device sends all the data. Hub receives it. Now the hub doesn't know that this data is meant for C. What it blindly does, it forwards. Suppose we have one more device here, D. Okay, it simply forwards the A's data to all other ports, blindly, because it doesn't know for whom the data it is meant. Okay, Okay. So because see actually when A is sending out the data, we have frame as user data. Okay, this is the frame which is being sent out. Okay, we have user data, nothing but 0101, anything. Okay, and here we will have source MAC address, we will have destination MAC address. Source MAC address is nothing but the actual physical address of A. Okay, destination MAC address is nothing but the actual address of C. See here, address of A, address of C. Now hub doesn't have access to all this. Hub will not go and see this MAC address into this frame. Okay, That is the reason it's called as dumb device. And as hub doesn't have access to the data, that is the reason it is a physical layer device. Okay, any device which has access to the data, okay, that is nothing but data link layer device. Now hub doesn't have access to this MAC address, this data. Whatever it comes to him, it's like I'm your friend. Whatever you say to me, I'll just say to him. Okay, I will not ask, okay, whom you are actually saying to. Okay, I'll just simply broadcast. Okay, hence it is known as physical layer device. Why it is known as physical layer device? Because hub doesn't have common sense to learn the data. Okay, it just takes the incoming data, forwards that incoming data to all other ports. Okay, now what about ports? Okay, hubs ports nothing but come in a multiple of 4 actually. Okay, most basic hub has 4 ports, the others 8, 12, 16, 20, 24. Hub can have a maximum of 42 ports. 42 ports is nothing but this is also an advanced hub. Basically the hub will have these many ports at max. 42 ports is the maximum advanced hub. Okay, these many ports. Now let's talk about some interesting concept known as collision domain. Okay, collision domain. Now what is collision domain? Collision domain is nothing but the network segment where there is a possibility of 2 signals getting crashed with each other, or the data of 2 devices getting crashed with each other. Now suppose here the A wants to send data to C. Okay, at the same time suppose B is also willing to send data to A at the same time. Okay, now he sends out the data is present here in the hub. At the same time, if this B also tries to access this hub, I mean the medium, these 2 signals collide and the data is broken down, completely wiped out. Okay, bro, if me and you crash at some higher speed, we both will get washed out. In the same way, if 2 signals get crashed with each other, the data loss is compulsory. Okay, that is about collision domain. The network segment where there is a possibility of signals or data of 2 devices getting crashed with each other. That is about collision domain. Now the collision domain, if you see in the hub, it is one collision domain. Collision domain 1 or shared collision domain. Okay, this is a collision domain. Suppose A is sending out the data, at the same time B sending out the data, they must have to go through this collision domain at any cost. Okay, but the broadcast domain remains same. Okay, collision domain is 1, but the broadcast domain is correct. How? What is broadcast? First of all, what is broadcast? Broadcast is nothing but if the data is sent by one device, it must be sent to all other devices. Example, ARP request. ARP request is nothing but address resolution protocol request. Okay, as I say, if A wants to send device to C, it is sending to all of the devices, nothing but network bandwidth wastage. There is a wastage of network bandwidth. Even though the data is not going for B, it is still sending to B, it is still sending to D. Okay, that's nothing but network bandwidth wastage, right? Okay. Network bandwidth wastage. Now, dumb device. Okay, network bandwidth wastage. Okay, let's cover one more point: security. Okay, now if you see, as I said, A wants to send data to B. C. Let's suppose that was a secret personal message. Okay, and now it is sending to all other devices. Now, okay, Only, okay, B, suppose I am good person, okay, even if some other's data come to me, I'll reject it, I'll say it is not mine, I'll not see, okay. Some devices, suppose some devices are malware devices, I mean they are infected with some virus, okay. What the virus is doing? Collecting all the data which is coming to that device, okay. Now the data comes from A, but it is not meant for B, it is not meant for B. The B, what if it still accepts the data? The personal information of C got leaked, right? That is nothing but security concern in the hub is more. In hub is more. Okay, this is nothing but the main case. Okay, now the hubs are of 3 types. No, not 3 types. For now, let's learn about 2 types. Okay, one is active hub. Active hub. I forgot to tell you one point. Hub is called as multi-port repeater. Hub is called as multi-port repeater. I explained about repeater. What repeater does? It takes the incoming weekend signal, amplifies it, regenerates it, boosts it, and sends out. Okay. Hub is called as multi-port repeater. Nothing but hub also, active hub. I'm speaking particularly about active hub. Active hub takes the incoming signal, okay, amplifies it, boosts it, regenerates it, sends it out. Okay, that is active hub also does this. So we can say if it is being able to do this, regenerate, definitely this has a power supply, right? Active hub, through the use of power supply, it is sending data to all other ports by repeating, I mean regenerating the signals. Okay, now we have one more hub called as passive hub. Passive hub is nothing but it has no power supply, no regeneration of data, I mean, or data or signal. Okay, let's come to what is bridge. As I told you, hub is a dumb device. It doesn't know whose data to send to whom. It just simply sends it. But here, bridge has access to the data. Okay, has access to the data. Okay, it learns the MAC addresses. It learns the MAC addresses. It goes into data, it learns MAC addresses. That is the main capability of bridge. Okay, but it doesn't deliver to the exact device. Okay, hub delivers to the, I mean, hub doesn't deliver to the device, but I mean, hub delivers to all the devices. This bridge doesn't deliver to the device, it delivers to the segment. Okay, so bridge is a networking device which is responsible for connecting 2 or more LANs, 2 or more, so connecting 2 or more segments of a LAN together. Okay, so bridge is responsible for connecting 2 or more segments of a LAN together. Okay, now how? Okay, suppose we have in our company we have HR department sitting here. Okay, these are PCs. These are connected to each other. We have one more side, employee department. Department. Okay. Now what will happen? Suppose if HR department and employee department needs to be connected, you can't just do like wiring. No, it's waste of time. What I will do, I will put a bridge here. So bridge what will do? It will learn the MAC addresses of all the devices connected to it. Now bridge maintains a MAC table, MAC to segment table. So suppose let's assume this is segment 1, this is segment 2. Okay, segment 2. Now what will do? Okay, it will create this device, okay, MAC and segment. Suppose this is device A, this is device B, device C, device D, device E, device F. Okay, A, B, C, D. Let's write now two. Okay, suppose A's MAC is actually the MAC is of 48 bits. Okay, but for now let's assume it's just of 4 bits. Okay, suppose the A's MAC is 0001 and B 0002, 0003, 0004. Okay, now A is residing in segment 1, B is residing in segment 1, C is residing in segment 1, D is residing in segment 2. Okay, now suppose D wants to send data to A. Okay, suppose B wants to send data to A. D creates the data, sends out the data to bridge. Now bridge, what it will do, it will check the destination MAC address. Destination MAC address is nothing but A's MAC address. A's MAC address is nothing but 001. It is of device A. It checks in which segment it is residing. It says it's residing in segment 1. So bridge says, okay, forward the data to segment 1. It will go here, it will go reach the device A, complete. Okay. As it has access to data, it operates at data link layer of OSI model. Because it has access to data, it learns the MAC addresses. Okay, now suppose A wants to send data to C. A wants to send. Now A will prepare data, A will send out. Okay, so C will receive it. The bridge will still receive it, but the bridge will discard the frame. It says that, okay, the data is meant for segment 1 only. I should not forward the data. Okay, understood? Okay, now how many okay, now how many ports does a bridge have? How many ports does a bridge have? So bridge usually has 2 to 4 ports. A bridge usually has generally 2 ports, but maximum it can be 4 ports. Like it is helping connecting 3 to 4 segments. Suppose we have an office, we have HR department, we have different teams. The bridge helps in connecting all of those. Okay. Okay. The bridge only supports half duplex communication. Hub also supports half duplex communication. Repeater also supports half duplex communication. Okay, you must know this. Very important. I said the number of ports, I said about the type of communication, I explained you what is the process. Okay, bridge is also, learn, okay, understand, bridge can connect 2 or more LANs together only if they are operating on the same protocol. Only if they are operating on the same protocol, okay. Bridge can connect 2 or more LANs only if same protocol. Got it? Suppose this is using token ring, suppose this is using Ethernet, it won't work. It won't work. They must be using the same. This also Wi-Fi, this also Wi-Fi, this also Ethernet, this also Ethernet. Only then this can connect with each other. Okay?